We did talk about the difference between parameters and arguments in the previous chapter. That's chapter 3 or lecture 3. And we saw that these are often used interchangeably. The book tries to stay consistent and try to refer parameters as those things that the function that's being called has in its input list, and whatever is calling the function will pass in arguments. So these are different. They're supposed to mean different things. Unfortunately, they're often used interchangeably. So what are the true meanings? Parameters. So when you talk about a function and it has some inputs, we call those formal parameters. That is, you're giving it a formal name, and that's what appears in the function declaration. If you give it names, that is, you don't have to in declarations. And in the definition, sure, you need names for each of the parameters, and those are formal names of formal parameters. So that's what you want to think of. When you look at the function, you see the parameters. When you look at where you call the function, that's when you should use the word argument. So arguments are what you fill in for a formal parameter when you call the function. So in the function call, you have a list of arguments, not a list of parameters. When you call a function, you have a list of arguments. Call by value and call by reference are simply the mechanism used to plug in those inputs. So I will try to stick to this notation that the book uses. I believe the book tries to stay consistent. Unfortunately, in general, if you look out, let's say on the internet, people mix up these terms all the time. Okay, so you can have a mixed set of parameters in your parameter list. You can combine passing mechanisms. So you can have call by reference and call by value, or parameter list you can say can include pass by value or pass by reference. This is probably a better way to term these things, that you're passing independently of the function. You can you can have multiple ways of passing parameters. You can have, this would be pass by value, pass by reference, and this is pass by value. This is again pass by reference. Just a simple ampersand tells you which one it is. Okay, so all you need when you call the function, so let's say this is the declaration. This is the declaration of a void function with 3 parameters. One int reference, one int, and then the third one is a double reference. When you call this, the only thing that you need to satisfy is that each of these things that you call with has to be assignment compatible with these things. So if you can say par1 equals arg1, and that is okay, then this will work. So arg1 has to be of integer type and it's passed by reference. This one is integer type and it's passed by value. Arg3 must be double. Of course, there's automatic type conversion too. So it has to be, the general rule would be that whatever you have here should be, or whatever you pass in here, for that is arg1, arg2, arg3, should be assignment compatible. As far as names go, you want to choose some meaningful names as much as possible. Choosing X, Y, Z, that's what I do for all the simple examples because I'm showing you syntax. But once you write programs that are actually going to be used, and that's what we want to get practice doing, you want to use meaningful names. So if you're doing simple tests of syntax, things like that, yeah, use IJ or XY, things like that. But as soon as you start writing assignments and things, you want to use meaningful names. And functions, as we've seen before, they are self-contained modules. They are designed separately from the rest of the program. Usually functions are assigned to, let's say, different functions are assigned to different people in a team of programmers. And each person must understand how to use each function properly. Okay, if you use parameter names that are the same as argument names, no problem, that's usually okay. It might be a little bit confusing, but in general, I don't think that causes a lot of confusion. Okay, so use function names with the same rules as basically choose meaningful names, things like that. Next, after this, now we'll move on to overloading. We'll keep revisiting pass by value and pass by reference, but overloading, apart from that, is the same as in Java. So there is the idea of a signature. The signature is the function name plus the list of parameters. And so this must be unique. That is, you cannot have two functions with the same name and the parameter list having the same type. So if you use different names for the parameters, that does not count. You need the parameter types to be either different or in different order. All right, so let's just take a quick look at that. So let's say you have two functions. They both have the same name, func, func. And in this case, this one has an int, pass by value, double pass by value. Second one has an int, pass by reference, and int, pass by value. So this is different enough that the compiler can decide whenever you call this, the compiler knows that if you pass in two ints, like in this case, x and y, the best match, and this is what the compiler will choose, will be this one. And you can test that because we're passing by reference, and in this one, well, actually both of them, we increment. And so if we see a change in the calling function, so wherever we call this, if we see a change in x, that means we know for sure that we call the second func, right? So initially x is 100 and you pass in x, it's passed by reference. If you call this, x will be incremented. However, if you somehow manage to call this first function, which is not passed by reference, then even though we have the same code, remember that this will not increment x over here. And as we saw before, you can have the same name, it doesn't matter. So you can change this to a. Of course, you have to be consistent. That is, you have to use a in both places. All right, so you can do that and do the same here. It doesn't matter. The names are not important. But you do want to use the same rules, that is, you want to use meaningful names, stuff like that. Oops. This is perfectly fine. Right. Okay, so now let's compile this. And if it works, well, if we see that after we call this func, if x is incremented from 100 to 101, that means we know that we called this function. All right, so let's try it out. Run this as a local C++ application. So here we see that x was incremented twice. So how can we force this to be a call to the first function? You can do something like change or cast this. You can use static cast, or you can use what we've used in Java. That is, in parentheses, make it a double. So now the C++ compiler will have to decide which one will it call. So this func is overloaded, and if you change this type of the second argument to a double, this is what we're doing here, changing this to a double, then we know that this, well, we can guess this will be the best match, and C++ will choose that as the function that's called here. But in the second call, these are both ints. We're giving two ints, and this is the best match. So remember that when you use call or pass by value, you don't have to do anything special over here. Right? You don't have to do anything special for x. You just pass in an int, and what's actually passed in is a reference to this x value. Let's check it out. Save this, and my prediction is the difference will be that it'll say x is 100. It won't increment x. Say y is 200, and it will return 300. And then the second time around, it will call this second func with the pass by reference, and so as a result x will be bumped up from 100 to 101. So it'll be different. Just the difference when we do this, when we change the type of y to double, is that this will be 100, this will be 101. Should be the only difference. Oops, forgot to compile, sorry. Compile it and then run it. Alright, so there we go. 100, because we called this func, which is a pass by value, and we got this one just because we changed the type of the second argument. Okay, so these things I'm hoping this is pretty clear. This is a very simple idea. We're doing overloading plus we're doing call by reference or pass by reference. Let's use that term, pass by reference, because it's actually the parameters that are important. Okay, so overloading, once again, just like in Java, the basic idea is the same function name, but different parameter lists. Now, what happens if we go back to here and try to do something like this? If you make this an int. Okay, so by itself, this is okay. The problem is that, so now C++ will say, wait a minute, what is this calling? So even though these are using different call by or pass by mechanisms, this is pass by value, this is pass by reference, when you look at how you call it, you call them the same way, and so C++ does not have enough information to decide which one of these overloaded functions you mean. Okay, so if you save it, you can already see there's an error, but if you try to really compile it, you'll get a whole bunch of errors. Now, all they're really saying is there's some ambiguity. It's not clear which of these overloaded functions you mean to call. Okay, I hope that's clear. It's the same, essentially the same rule as in Java. The only difference in this example is that we're using call by reference. So we need, if you have two functions with the same name, you better have parameter lists that have different type. And it doesn't have to do with the name. So you can check that by going back to Eclipse and calling. It's not because they have the same names here that's confusing. So if you say, well, okay, this can all be fixed by changing the name of this to AB or X. Let's call it X. Okay, so you might think, oh, this is okay, but no. Try to compile it, you'll still get the same error message. Nothing is different. So the names that you put here are really not important. The signature of this function is int ampersand int, and so you're passing, what you're going to pass in is two ints. Okay, so the function signature is the name and the parameter list, and it must be unique for each function definition. And so what this allows is you allow the same task to be performed on different data. So for example, let's say you have two functions called average. One has 2 inputs, one has 3 inputs. Right? That's typically how you use overloading. That is, you have different data that's passed into a function with the same name.